mass like thing, like that is just a ratio. Like,
Where was she from?
No, nowhere.
Okay.
It's like all rules goes.
You should get that as like a ratio.
Oh, thanks for coming again. I see nothing can prevent you from coming here. So, who we are and what are we doing here? What's the class name? Physical chemistry. But in fact, we are doing quantum mechanics, which is a natural part of the physical chemistry. So, what are our objectives or objectives? How to pronounce correctly? Just help me. Objectives or objectives?
Objectives.
Objectives. Okay. What are they?
Understand duality.
Oh well, duality, causality. We all heard, but what from more mathematical rigorous way to get basic principles and convert ideas into language of math, so that we can explain more practical examples. On your language, duality of what?
In a wave and particle.
Wave and particle of what?
Electron.
Yes, of electron. So we do not care about light, we don't care about photons for a time. Maybe by the end of the course we can tell something like photochemistry. Or there is a new area in experimental chemistry, microwave chemistry. When you take a container with reaction, just put in microwave. Really, there are a lot of discoveries and publications. It changes how the reaction is going on. Even if you do not bring it to boiling, microwave changes it, and one doesn't need specific equipment. Okay, principles for electron motion, because electron is so energetic that it doesn't want to stay still. Waves, which can be traveling and standing, right? I do not have pedagogical talent to ask the question correctly. Standing and traveling can be what? Waves. We got an equation that generates traveling and standing waves. Hopefully. So if you take an f function, apply second derivative over space and over time, and function should depend on at least these two variables. Put somewhere 1 over velocity of this wave, then such equation is expected to generate waves. In simplest way, infinite cosine, in generally some traveling waves, wave packets, and we are potentially able to deal with math that is responsible for wavy motion. I wasn't lying, but probably I broke your expectations. This equation, wave equation, has nothing to do with electron. This equation is good to describe electromagnetic waves or guitar strings or like drums surface, but not electrons. If you want an equation for electron, it should be not second derivative over time, but first. And there are reasons for this. But to come to this ultimate truth, we will spend a little bit more time. Which movies did you watch? No, not general. I know most of you watched next episode of GOT, but which movies did you watch in class before we wished each other a nice weekend?
Of the orbitals?
Yes. So what do you remember from this movie?
Full numbers give you nice round circular orbitals, while if you had like a partial orbital, it starts getting funky.
Yes, excellent. So these images were a rough visualization of the Bohr's orbitals, which were like breakthrough at the beginning of 20th century for explaining atomic spectra. So there was a thought that it is a planetary type motion, like electron like a planet circling around nuclei, but it can circle not at any distance and any velocity. There are specific distances and specific velocities that give discrete integer numbers of this distance times momentum, which is angular momentum, right? It is what you were always enjoying in your kindergarten, Bohr's orbital. And as, any chemist is well aware of the orbitals, right? SPD, which somehow related to this. But we want to grow as intellectual elite of the planet. We want not just absorb blind, information as a disk drive and then reproduce it. We want to develop our own ideas and connections between pieces of information, being able to generate new information. So what are the principles? What do we learn from this Bohr model and this movie? So something wavy is going in circles, and this something is happy to make discrete number of oscillations. Please object if you do not like this verbalization. Okay, no one objects, then it is ultimate truth. Democracy. But we need to get an idea what is moving, what performs these oscillations, and then later how to develop mathematical tools to describe it and project it on something more complicated than boring circular orbits. So we will make intellectual effort to get some more specific ideas. What is changing along Bohr's orbitals? What is oscillating? Why there are discrete numbers? And in fact, we don't care about Bohr orbitals. It is only a toy model to develop ideas. How will we get through? What are our plans for today? We'll have two sections. During the first section, you can lean back, turn the lights on, take popcorn, and fall asleep. I will give you a sign when to wake up and memorize or take records. It will be a little more than necessary math, and it will be a little more than chemistry in first section. Second section, it will be boring as well, but you cannot avoid it. Second portion will be I'll try to recall what are complex numbers. If you are happy with them, complex, not like, oh, they're so complex, but it is a term. And many of you may be well aware of those, and then you can keep leaning back and sleep until the end of the meeting. But if you don't, I just quickly remind. So, two things, two chapters. First, it will be our travel into world of physics. What is laziness? Try to give some definition, because laziness is an engine of a progress. People design new tools when they are lazy to do it by hand, right? But what is laziness? Try to work. Huh?
Wanting to spend like the least amount of energy possible.
Ah, excellent. Probably I cannot find better, but maybe other same idea but different words. Energy is too complicated, but if I lay back on couch, I do not want to do anything. Right? So I want to minimize not only
Effort.
minimize effort, good. What else? I just want you to design the right word. To minimize. When I do something, I perform
Work.
work, yes. I act, I do action. When I do nothing, I minimize my action. So first section is least action principle, which most of us are well familiar in regular life, but it is one of the fundamental cornerstone of modern science. And there are mathematical formulations for it. There was Newton with his equation of motion for any like particle or chair or wheel, right? So like, give me sign if you do not know Newton's equation of motion. So no one gives sign, so I shouldn't show it. Acceleration equals force divided by mass, right? And if one solves it as differential equation, one can get a trajectory, a law of motion, how a particle moves. Position is function of time, right? All correct, is good. Well, respect to Newton. But it is too simplified. There are more advanced, more philosophical ways to get the same answer with more boring and complicated theory, which can be generalized to something more complicated than just set of particles. And the competitor of, Newton was British, and his competitor is from France. Compete. So the name is Lagrange, and there is a Newtonian equation of motion and there is a Lagrangian equation of motion. Why should we drive our young brains to this new piece of information? Because we will answer our main goal for today. This will be also cornerstone to answer or get an idea what is oscillating or what is changing along the trajectory in Bohr's model. Least action principle, Lagrangian mechanics. Again, do not concentrate. We will, I promise we will never do homework based on what I'm going to say. It's only for concept. So it's completely understandable if you'll be sleeping during this piece of calculation. Where do I go? I'm going to zoom into the screen. Okay. So this is something you remember from, you've got the general idea. Now I will be trying to give illustrations and details. You remember these movies, right? And here is the angular momentum, which is distance from center times momentum. And this stuff takes discrete values times Planck constant. It is what you learn in kindergarten when you look at Bohr's model and planetary model of atom. Oh, if it would be like freshman course, or if I would think of you not as intellectual elite, but as a kid, I would show portrait of Bohr, history which year it was developed. But let's go quicker, and you can find portrait of Bohr in. So discrete, and if it is not discrete, then something wrong is going on. So we are looking for alternative way to get answer to main question of mechanics, to find trajectory of a particle as function of time. Simplest way is to solve Newton's equation of motion, but there is an alternative way. So suppose you do have a trajectory, position as function of time. the strange symbol is t, which is like x is function of t, something moving. Then at each point of time, you can find velocity as derivative of position, right? You can find kinetic energy, and you can find potential energy. Like kinetic energy can be this mass times velocity squared divided by 2, right? And potential energy, well, if it is electron, it is, let's, something simple, kx squared O2 for spring and mass. It's not general, it is only one example, but you can get it. And the values of this energy will be different at each point of trajectory if there is a motion. Where do we use it? Where one can use it? One can take kinetic and potential energy as a function of time and build the total energy, T plus U, right? It is what you were doing if you were taking some physics classes or if you during your science in high school. Why don't we replace plus with the minus? Just as experiment. So T minus U and call it different letter. So H for Hamiltonian and then for Newtonian mechanics and L for Lagrangian. So if you design something, just call it after your name and make others to repeat it. So there is, by the way, what is the dimensionality of this L symbol and H symbol? Dimension. Something simple. There is no trap. There is no trick in this question.
One-dimensional in this case?
No, not dimensionality. Not like 2D, 3D, but is it like
Energy?
yes, energy. Both H and L dimensions are energy. Okay, and here's the thing. If one takes the value of this L thing, L variable, at each point of time along the trajectory, and adds it together, integrates, then it will be a magic tool. It will be one number for each trajectory, but there are theorems and there is a lot of experience that only those trajectories in nature which minimize this integral are allowed to exist. It's on one hand it is observation, on the other hand there are derivations. So if you do S equals integral L dt, then one call this thing action from initial time, and only those trajectories that minimize action are observed. So whatever is moving moves according to minimal action or least action principle. So laziness in action. Good. So now you are certified experts in advanced classical mechanics. You can go to physics department and get credit. Actually, they studied for a semester. Same thing. Do not be scared. I just exercised how to type equations. So what do we get here? So along trajectory, you can get kinetic energy, you can get potential energy, you can build kinetic plus potential or the subtraction. If you build this action variable, it is a criterion. So you can build trajectory without solving any equation by random number generator. But then, if the action will be minimal, this is a correct trajectory. If it will be maximal, it is a wrong trajectory. Okay? If you're sleeping, that's fine. This is not for chemistry, and this will not affect any of our And here, from this least action principle, one can make an equation of motion that will be a replacement of Newtonian equation of motion, of Newton's second law. So derivative over position equals derivative over velocity is another derivative over time. And if you give the same answer for any system, and it is more general because it can be applied to something more complicated. The only thing, so if you are sleeping, you may wake up and concentrate. There is a time dimension, time and energy. So the magic thing that gives answer to any modern science is energy times time. And it will be this action that we want to minimize. Okay? There is an important observation that we can derive or just believe. So what is the dimension of the stuff that is being quantized in Bohr's model? And if we do not know the answer, we need to derive. So it is distance times momentum, which is, okay, let's write it like x times, what is momentum? Is mass times velocity. Right? So it is distance squared, mass in the first power, and we can put t squared here, but to avoid line and keep our reputation, we should put t in the first power in the denominator. So I replaced t in the denominator by t squared in the denominator, but multiplied by t. No line, all pure by now. Now, which equations from previous slide pop up in your head by looking at mass times derivative, second derivative, or first derivative of distance over time squared? You wanted to say this, right? So what is this? Energy, kinetic energy, right? So we can identify this term as energy, and this is as time. So here is something important. The dimensionality of the stuff that is being quantized in Bohr model is energy times time, which is the same dimension as action. And Planck constant also has the dimension of action. So it is not math anymore, it is now our intellectual analysis. So if we do have something that is getting quantized and it has dimensionality of action, and this something, if we divide it by a Planck constant, which is also in a dimension of action, then we will get dimensionless angle, the phase. So we can think of the electron moving on the circular orbits and accumulating action from the initial to final time that we explore. So electron accumulates action. But if we divide it by Planck constant, it will be angle, it will be phase that can be fed into oscillatory function. So where are we now? What did we get? I have communicated you the main idea. Now we need to maybe verbalize it better or wrap it up. So, and you shouldn't underestimate, you are making a major effort that took 100 years for humankind right now. The rest are boring math and technical details that you can hire someone else. Now it is something that we need to think ourselves. So if a particle moves along trajectory, it accumulates action. But if you divide this action by Planck constant, it can be associated with the angle, degrees or radians, that it's also accumulated during the trajectory. On another in-Bohr's model, we have this cosine oscillatory functions. And of course, oscillatory functions have argument, have angle inside them. Why don't we hypothesize that this angle, this argument of this trigonometric function is actually action divided by Planck constant. So action that can be computed by this apparatus of classical mechanics. So during the motion you accumulate action, but if you divide it by a constant, it means during the motion you accumulate phase. Motion is accumulation of phase. And this phase is argument for some oscillatory function. Objections? Then it is ultimate truth. So, argument of Bohr's wave is action divided by Planck constant. If you object now or stay silent for until the end of the course. Are we happy? Are we done for today, or we have something else to complete? So you did a major breakthrough. It looks a little like jelly, not very solid, but it is a major idea that will help you to become excellent chemists in the future. It helps to understand stability, reactions, and what is going on the atomic level for atoms and molecules. No philosophical principles anymore, but now we need a mathematical tool. We need to be, I gave you a warning, that you will be warned for the rest of the lecture. Now we are done with physics and we are going into math. It is what we do in chem courses. So, when we were thinking, it's just action divided by Planck constant is something that should be integer. So when we were thinking of these movies, images, videos of the strange stuff circling around, you were thinking that a wave is a harmonic function, something oscillating, sine or cosine, trigonometric function. But is it general enough? Can we fall into trap and come into situations when these functions are not good anymore? Like interpretations of these waves, of something that moves around in the electronic wave, is to be discussed later, but there are two major interpretations. One is that it is a probability amplitude, and probability is typically between 0 and 1, positive. Another interpretation is that it is density of electrons, so number of electrons per unit volume, which also should be positive. And cosines sometimes are getting negative. So maybe we need to do something with them. Maybe it is not ideal, it's just a little bell. But if it would be cosine, we would say that electron is cosine of action divided by Planck. You need to produce it in public, it is wrong. we are going to be much more rigorous.